Now we have to talk about symmetric and antisymmetric tensors. For that, consider a tensor Aij. This contravariant tensor. If the coordinates I and j are interchanged, we can get a new tensor Aj. If Aij equal to Aj, then Aij is said to be symmetric. The same logic is true for the covariant tensor Aij. This is a covariant tensor because these are all present in the subscript. Indices are present in the subscript. If Aij equal to Aj, then Aij is said to be symmetric. Suppose a mixed tensor is taken for our account, Ij real. In this mixed tensor, if we interchange the two indices I and j, now we can get Aj of L. If Aij L equals Ajil, then Aijl is said to be symmetric. Now we have to present in a statement. If two contravariant or covariant indices can be interchanged without altering the sign of the tensor, then the tensor is said to be symmetric. Concerning these two indices, the meaning is, with respect to the two indices I and j, the tensor Aij is symmetric if there is no change in the sign of the tensor. If you interchange these two indices, if Aij equal to Aj, then the given tensor Aij is said to be symmetric with respect to the two indices I and j. The given tensor may be covariant or contravariant. This is contravariant, this is covariant. If two contravariant or covariant indices I, j, in this case these two are contravariant indices. Here I and j are covariant indices. If two contravariant or covariant indices can be interchanged without altering the sign of the tensor. Then the tensor is said to be symmetric with respect to these two indices or concerning these two indices I and j. Now we have to give the example. A ij equal to a ji. This is an example for contravariant. If it is covariant, we have to write a ij equal to a ji. Now the tensors aij and aij, this contravariant, this covariant, are symmetric. If you take a mixed tensor, now consider a mixed tensor for a tensor of higher rank. Higher rank means mixed tensor, rank I, J, K, L. This tensor of rank 4, high rank tensor. 3 contravariant term and 1 covariant term is present. If A, I, J, K, L is equal to A, J, I, K, L. Just to have interchange these two indices I and J alone. A, I, J, K, L is equal to A, J, I, K, L. Then the tensor A, I, J, K, L is said to be symmetric with respect to indices I and J. Now we have to go for the antisymmetric tensor. In this case, if Aij equal to minus Aji, or if Aij equal to minus Aij, Aj, not Aij, this if Aij equal to minus Aj, this is in contravariant form, this is in covariant form. If interchange these two indices, if the sign of the vector, sign of the tensor is changed, this is called anti-symmetric or skew symmetric. In the case of mixed tensor also, we can make the same argument. See, in mixed tensor A I J K L, which is equal to minus of A J I K L. If the indices I and J are interchanged, we can get A J I with a negative sign. Now the tensor A is said to be antisymmetric. Now we have to write the statement. Here the same statement you have to repeat. If two contravariant or covariant indices, can be interchanged with altering the sign of the tensor. That means the sign of the tensor is changed to negative. Then the tensor is said to be antisymmetric concerning these two indices. Now we have to write. If two contravariant or covariant indices can be interchanged with or without, with altering or changing, altering the sign of the tensor, then the tensor is said to be antisymmetric or skew symmetric concerning these two indices. Example, Aij equal to minus Aj and Aij. This is in contravariant form, this is in covariant form. Minus of Aj. In the mixed form, we have to write this Aijkl, which is equal to minus of Aj. Just I and J are interchanged as J and I. Then K is present as such L. Now we may say that the given tensor is antisymmetric with respect to the indices I and J.